Alright, today class we're going to talk about experimental and theoretical probability. Now, one of these you've actually pretty much already learned, and the one that we already talked about yesterday, we just didn't call it that, is our theoretical. Alright, didn't know that's what we talked about. Okay, we talked about theoretical probability. Okay, when we used simple events, probability, there we go. And using simple events, we were able to come up with theoretical probabilities of certain things, like how we talked about the, so this is just your uniform, what should happen. Man, my spelling's on my thing right now. Alright, so uniform, it's what should happen. Like when we have a dice, right? A six-sided number cube, as your book calls it, a six-sided die. The chances of you rolling a 6 is 1 to 6, right? That's the probability. 1 to 6. Sometimes written as 1 to 6. Okay, that's our chances of rolling that 6 on the cube. That's theoretical. That's not saying that we actually did that in once every 6 times. That's where this new part of our lesson comes into, the experimental part. Okay, so experimental did it again. Probability. This is based on relative or what actually happens. Probability, okay? So this is based on what actually happens, a relative probability, what is actually happening. Okay, so if we actually roll the dice, we'll say we rolled it 18 times. So we took this same die and we rolled 18 times. Out of those 18 times, we rolled 2 6s. Alright, so that means the experimental probability says that I got 2 out of 18. That's the probability that I would get a 6. Now, just like fractions, just like ratios, we have to simplify this. Okay, so to put this in simplest form, I could divide both top and bottom by 2, and I could get 1/9. So my actual probability after I roll the dice 18 times says that 1 out of every 9 rolls is going to give me a 6. But theoretically, it should be 1 out of every 6 times. So how could this be wrong? Why does it not show up exactly 1 out of 6? There's a couple reasons why. It could be the dice is broken, right? Maybe the dice is weighted in a certain way. It could be that we just haven't rolled enough, right? So maybe we just need more experiments. And so need to roll more sometimes is what so we need to have a larger number of experiments. Alright, there needs to be more rolls in order to fully prove what's happened here. Alright, so if we rolled the dice maybe 100 times, maybe we'd get closer to 1 out of 6. Alright. So let's think of another probability here. Let's say like a coin. Alright, so if I have a coin and I flip this coin, so here's another example. We flipped it 50 times. Alright. Now, ideally, what would the probability of a coin flipping to heads, right? What's the chances of it landing on heads? Theoretically, the theoretical probability would be 1 out of every 2 times, right? There's only 2 sides to a coin. So we go ahead and we experiment, and what ends up happening is we end up getting 28 heads to the 50 flips. So then writing that down, we get a 28 out of 50. And so then to simplify that, we'd have to then go down to 14 25ths. So we divide both the top and bottom by 2 to get there. 14 25ths, that means 14 out of every 25 flips gives me a heads, which is 56% of the time. And I can figure that out by multiplying these by 2, because percentage is just out of 100. So 28 times 2 would give me 56, and that's how I got 56% so quickly. Okay, but this is my experimental probability. Okay, so after I experimented, that's what I ended up getting. Alright, well, sometimes we can use these experimental probabilities to predict other things, such as if we had a bakery, okay, or we made a bunch of cookies, and so we wanted to make cookies as a class, and I'm trying to decide what I'm going to make. So I go to a bakery and I ask, okay, what do you sell to 11 and 12-year-olds? Alright, what do 11 and 12-year-olds get? And so the baker tells me, alright, well, he says there's 3 kind that are purchased. One is the chocolate chip. And out of the last 100 students that he had, 11, 12-year-olds, he said he sold 58 chocolate chip cookies. Then there's the snickerdoodles. He said there was 18 that bought the snickerdoodles. And then there was the peanut butter cookies, which, hold on, I gotta do my math. 6, 7. There was 24 11, 12-year-olds that had peanut butter cookies. So then I'm like, okay, well, I don't want to make 100 cookies. I just want to make 20 cookies for my class. And I want to make sure, I should believe that everyone would get the one they want based on these numbers. So looking at these numbers, I add all these up. There are 100 cookies here. That means I need to figure out chocolate chip to total cookies. So my chocolate chip to total is 58 to 100. But I want to reduce this to 20 total. So one way I can do this is by creating proportions. Right? So we had our 58 to 100 should be equal to, I should have 20 students. So I want to know how many chocolate chips I'm going to make. And I'm just going to change it to just 1C for my variable. We'll put 2 C's, it gets confusing. We want 1 variable. And then I can solve for C to find out how many cookies am I going to make that are chocolate chip. I can reduce this, divide those both by 2, I get 10, and thinking 29. And so then I have nowhere else to reduce, so then I can just multiply this through. I get 29, now multiply it through. We have to cross multiply. So then 100C is going to equal 290. I can divide both by 100. Why does that not seem right? What did I do wrong? I did something wrong. Why am I doing that wrong? We can't cross simplify. That's a terrible idea. We don't want to do that in this problem because cross simplifying is only when you're multiplying. Mr. Cunningham had a minor brain fart there. Let's fix that. So we don't want to do that. If you're watching the video, go back to this spot and then laugh at Mr. Cunningham for being wrong. Alright, so we can't cross simplify because we're looking at a proportion. What we can do is we could simplify this, right? So we could divide both of those by 2, and so we could simplify that to make it 29 and 50, but we can't cross simplify when we're talking about a proportion. Okay, we only cross simplify when we're multiplying. Okay, now I'll cross multiply and I get 50 times c equals 29, so I get 580. Divide both of those by 50. I know those can simplify down to c. My zeros can cancel out, so I'm really just doing 58 divided by 5. Goes in once. 0, bring down my 8, another 1. And so what I'm going to end up getting here, 3, 0, so 11 6/10 of a cookie. To be safe, I would probably round that up and say I'm going to make 12 chocolate chip cookies. Okay? Then I can go back and I can try and find out how many snickerdoodles I should make, how many peanut butter cookies I should make, using the same process. Hopefully not making the mistake of cross-simplifying each time, but that's the whole process, to find that 12 chocolate chip cookies is going to be sufficient for my 20 students, since on average we saw 100 there. Okay? Alright, sorry for my mix-up. Hopefully everything works out for you. Good luck, and keep on working hard. If you have any questions, let me know.